to find the vertical asymptote, you set this equal to 0 and solve it to find the vertical asymptote. So this is negative 8x equals negative 28. Divide by negative 8. And you'll get x is 3.5. Okay, your horizontal asymptote. These degrees are the same. So if the degrees are the same, you look at the coefficients. So that means your horizontal asymptote is y equals negative 1/2. Because 4 divided by negative 8 is negative 1/2. Okay, let's find our zeros. To find your zeros, you set the numerator equal to 0 and you solve. So please help me out, guys. I'm going to need to know what negative 19 divided by 4 is. Please shout it out when you have it. Negative 4.75. Thank you. All right, now let's figure out what the y-intercept is. We're going to plug in zeros everywhere. So if you plug in a 0 here, that goes away. Plug in a 0 here, that goes away. I'm left with 19 over 28. What's 19 over 28? Thank you. All right. So what you're going to do is just estimate. So I'm going to have a vertical asymptote at 3.5. That's right here. I have a horizontal asymptote at negative 0.5, negative 1/2. I have a 0 at negative 4.75, right around here. And I have a y-intercept at 0.678, so that's around right here. Okay, so I assume my graph will look something like this. You can do an interval table to make sure. Okay, here's another one. You're going to have to factor first. So I'm going to factor the numerator. This can be 400 and adds up to 4. What would that be? I need two numbers that multiply to 400. Oh, first, let me go ahead and just pull out a 4. Let's do that first. Divide everything by 4, we'll get x squared plus 10x plus 25. So two numbers that multiply to 25 and add to 10 are 5 and 5. So this will be 4 times x plus 5 times x plus 5. So that's my numerator factored. If I factor the denominator, it'll be 3 times x plus 5. So notice this cancels with one of these in the denominator. So now my answer is y equals 4/3 x plus 5. This is my new equation. So I'm going to answer all of my questions based off of this new problem. So let's figure out a vertical asymptote. Well, your vertical asymptote, you will not have one. I can make this a little clearer for you by putting this in the numerator. If you equal the denominator to 0, 3 does not equal 0. So there is no horizontal asymptote, or no vertical asymptote, sorry. Okay, the degree on the top is bigger than the degree on the bottom. So that means for horizontal asymptote, you also have none. So we don't have any horizontal or vertical asymptotes. Okay, for your y-intercept, you plug in 0. So we'll get 4 times 5, which is 20 over 3. For x-intercept, we equal the numerator to 0 and solve it. So we'll get x is negative 5. And my hole, we will have a hole. Do you guys remember how we know if we're going to have a hole or not? Yep, if it cancels out. So we canceled out the 5s, the factor x plus 5. So that means I'm going to have a hole at negative 5. If you want to know the exact number, plug this negative 5 into your new equation to figure out the y value. So I'm going to plug in a negative 5 here, and I get 0. So I'll graph everything. Negative 5, 0. is a hole. So that means, guys, I actually don't have an x-intercept. I just have a hole there. My y-intercept, can you guys calculate what 20 over 3 is? 6.6 repeated. So that'll be up here somewhere. So this is my line. Notice it turned into a linear equation, mx plus b. So that's your line. We do not have an x-intercept because your x-intercept turned out to be a hole. Okay, next one. I'm going to let you guys try this one, and I'll pause here. Guys, you should have canceled out this x with one of the x's in the denominator. So your new equation is x minus 5 over 2x. That means we do have a hole because we canceled out an x, correct? So your hole, whatever you canceled out, equal it to 0. So that's your hole. Now you answer the rest of the questions with this new simplified function. So for vertical asymptote, you should have gotten 0 because you set this equal to 0 and solve it. Your horizontal asymptote, your degree in the numerator is the same as the degree in the denominator. So you look at the coefficients. So it'll be y equals 1/2. Your zeros, you set the numerator equal to 0 and you get 5. Your y-intercept, you plug in zeros everywhere. So let's do that. You plug in a 0 here and you plug in a 0 here. But 2 times 0 is 0. You cannot have 0 in the denominator. So that means you do not have a y-intercept. Now, to find the x value of the hole, you would plug in a 0. And we got undefined again. Okay, so let's go ahead and graph this. Your vertical asymptote is right here, which makes sense. You can't be on this line. That's why we have holes here. Your horizontal asymptote is at 1/2. You have a 0 at 5. And you don't have a y-intercept, which makes sense because you have an asymptote on the y-axis, a vertical asymptote there. Okay, so if we graph it, it should look something like this. I can just tell what this is going to look like because I have to go through this point and it's going to mirror. Because these graphs always look like this or they look like that. So if I drew one down here, I knew the other one would be up here. But you can always check with an interval. So let's look at vertical asymptote. Is it 0? And you have a x at 5, a 0 at 5. So if I plug in numbers less than 0, let me clean this up. So look at numbers less than 0. So we can plug in like a -1. This is negative on the top and negative on the bottom. So that's positive. So that means this was on the positive side, like we had. And then between 0 and 5, let's plug in like 1. So I'll plug in a 1. So it's negative on the top, but it'll be positive on the bottom if I plug in a 1. So that's negative. So notice between 0 and 5, you see how I'm down here on the negative side? And then after 5, you go above. You cross at 5 and you'll be positive, but you won't touch the asymptote. You'll be between 0 and 1/2. Still positive though.
So when can you cross the horizontal asymptote? When there's a point?
You'll probably cross the horizontal asymptote when you have something like this. These are your vertical asymptotes, and this is like your horizontal asymptote, and you have a point like here. It'll probably look like that.
and that's a case where you would cross the horizontal asymptote. You won't really know until you do the intervals and see.